talk about requirement determination, right? So now we continue after the requirement determination to requirement engineering, so that we learn many techniques, right? That how can we acquire and talk to the user, interview, study the document, looking at the existing system and so on, in order to understand what's supposed to be the requirement. Then we need to properly model the requirements, and that is what we call requirement engineering as well. So before we go into some of the details, let us categorize or classify the requirements into two broad types. First, we call user requirements. Second, we call system requirements. They are kind of very overlapping somehow, and then closely related for sure. Actually, user requirements are intended for kind of communication purposes, to communicate, to confirm with also the users. And the target is actually, we provide these kind of documents, diagrams, and so on for user communication, written for users to understand and to confirm us. And okay, let me get mine. Okay, so it can be statements, it can be documents in human language. It can be certain diagrams, of course, because it becomes precise and non-ambiguous if you draw some diagram as well. It's easy, right? Sometimes you explain everything in text that is too long, okay? And the focus is to explain about the system services, the operational details, and so on of the system for the user to confirm with us. Next thing is system requirements. The main purpose is kind of basically their structured document describing the functions, the service, the operations, the constraint, and so on. And usually it will be for communicating and for confirming all the things, but will be more detailed, and sometimes could be most of the time as well. They are used to kind of communicate as part of a contract. But anyway, even we talk about agile approach, in which we will talk more detail of the agile approach in the after mid-semester. We practice when we really have extensive practice in the project, then we will bring the agile approach. Even agile approach say that we need to consider working system over contracting issues and so on. But in reality, right, when you hire someone to do things, you somehow want to secure yourself with certain contracts and what to tie everything tightly, right? That, oh, by way of hiring you for the value of 1 million baht project, I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? You want to be sure that you get most of the things or as much as possible, and draw and write things in the contract. So a way to write the requirement in the contract is to kind of secure, right? If you are the contractor, you are the one who outsources the service or hire someone, you may want to be sure that at the end of the time, the project, you pay something and you get something worth the value of payment. So this system requirement document usually explain all these things. But as I mentioned, it could be very challenging for something complex, something big, and that you already read from many articles and we discussed, that sometimes when you still have something not very 100% clear, but you already have to write the contract to say that this person has to deliver 1 to 100 things, right? Those 1 to 100 things, finally, you may find out that, oh, what you really need are just 1 to 20. The remaining are something you will just fill the money with something that they have to do. And maybe that 1 to 20 that you need, you also want something else in addition to. But once you already tied everything with the contract, it would be very difficult unless you have a very flexible management with the outsourcing, the developer team, and so on. So that is the challenge when you have or hire outsourcing company. But of course, if everything is in-house, right? Then we are in the same company and organization. I think it is much easier to do some kind of negotiation. That is why in the big company, they do have their own IT team and then working on the project details, and so can have more adaptation and flexibility in that way. But anyway, so back to the requirements. These are the two broad types of requirements: user requirements and then system requirements. So this is more or less in the overview level in terms of user requirements. In terms of system requirements, there will be more of the detail and then confirm exactly the functions, the service, the operations, and the constraints. And then if we talk to the requirements in another dimension, we can divide the requirement into what we call functional and non-functional. Okay. Okay. I will not explain, but let you guess. Okay. First, from the name, from the terminology we said, right? Functional requirements, non-functional requirements. What do you think they are? And if I'm giving you here a list of requirements from A to G, do you think they are functional requirements or non-functional requirements? Just okay. It's fine to guess first. Then we will go through each of them together. Okay, 1 minute has passed. Am I too fast? Any? Can I get your response? Okay. I guess it's fine, but try to kind of make your own definition, right? Oh, functional should mean something like this. Then you can choose appropriately, right? That which one supposed to fall into functional or non-functional. Okay. First one. The system shall prompt for username and password. Functional or non-functional? I heard functional. Okay, so let's say like this. This is functional, this is non-functional, 1 or 2, right? Whether you choose choice 1 or choice 2 for all the remaining example. Okay, Piranat, you also choose A, functional. Okay, then A, most, oops, what? Okay, you said functional, right? For me to write down, okay, I have not say that it's correct or wrong. B, all data will be backed up daily. 1 or 2? I saw those who answer. There are 3 or what? 2, right? I saw 3 somehow. Okay, those who answer, that you answer 2, but there are also those who don't answer yet. I'm not sure, and you cannot make a decision right now, right? But most of you who answer say non-functional. Yes, I just say short and F, okay. So maybe N to make it short. Okay. C, help text will be provided in Thai, German, English. Functional or non, I see both. Yeah, I see both now. But majority, can you make it clear? Up, high. Here, majority of this side are functional, but some non-functional. Majority of this side mixed. Okay, so this is, I still say that we don't have any clear consensus. Okay. All right. D, the system shall be easy to use and extendable, I think. Extend. Okay. Functional or non-functional? Okay, most of you go for a non-functional. Okay. E, user shall be able to search for product by name or price. I think this is pretty clear answer by all of you. Up to million user profile can be inserted. I see functional here, some non-functional here. Also big mix. I would say there's a mix of answer. What did you answer, Pirana? Non-functional too. Okay. The last one. System shall calculate daily sales amount. Yes, I see a clear functional. Okay, so I think you have somehow some definitions in your mind, right? This way of you know, you learn, many of you are data science students, right? And I think many of you took already AI course. Did you? I think so. No? Yes, the AI with Professor Doom. Oh, not if you are not, right? The Professor Doom deliver you AI course last semester. Any of you took it? Only one? Oh, okay. Really? Okay. But anyway, I have a question. Whether you take AI or not AI, not taking, this can be, you may know this. When we talk about reasoning, there are two broad types of reasoning as well. One is called induction and deduction. Inductive reasoning, deductive reasoning. Okay. Anyone knows what are they and how are they different? No, not sure. Okay. I give you some. I'm not going to say anything now. But maybe if you're interested in, you find out a little bit later. And what we try to do here is deductive or inductive. Okay, anyway, so let me give you some easy definition. Functional requirements mean statements or the requirements, of course, the statements that explain about the requirement, right? Statement of services, about the system, about the service, how, sorry, I think I have something wrong with my English here. Statement of service, the system should, okay. Statement of services that the system should provide. What kind of service the system should provide and how the system should react to input and behave in particular situations. So actually from the word functional requirements, you already have some idea that it means how the system should function, what kind of functions the system should deliver. Okay, that's the meaning of functional requirement. So easy way is to just think what functions the system that you are modeling the requirement, right? What functions that the system should offer. Okay. Second, non-functional requirements. Actually, it's not talking about the thing that the system must do or perform, but it's about some properties, some constraints, some preferable conditions of the system, such as timing constraints, constraints on the development process, and some standards. These are non-functional. It doesn't say that, for example, if your functional requirement would say the system should take input, which are username and password. I mean, should authenticate by username and password, should allow user to input the data, should display the report, should show the calculated amount, something like this, right? This is the functional requirement, what the system should do and act, what kind of action things system do and give. Non-functional are somehow properties, such as system should respond fast within 10 milliseconds after the user click on the query button or something like that. Okay. Okay, so let's make some table to compare them. Functional requirements, they explain the product features, but as I said, non-functional are more on the properties of the product of the system. Easy to use, these are properties, not the function, right? System should be easy to use. System should be available, mean run 24 hours without stopping. This is property, not function, right? System should, okay, describe the experience of the user while doing, describe the actions of which the user work is concerned instead of describe the experience that the user have while they are using. So more or less non-functional will be on the, if it is about the user experience, here it's the usability, right? User interface issue, easy to use, as I already mentioned. And as I already mentioned, another point is about usability, easy to use, user experience. And we will talk about this later on. Use case. But when it is a functional requirement, you should be able to capture them in use case model. So you are describing that certain user will perform some action through the system, such as search for product. This is an action, right? That you want the system to provide to the user to perform. Search for a product, place an order, track order delivery, make a payment. These all are functional requirements. Okay. More or less non-functional talks about global constraints, results in development cost, operational cost, behavior analyzed by drawing. Okay, these are more or less on the. Another keywords, there are properties and qualities when they are non-functional aspects. Okay, so if we further categorize, I think here, right, we do have requirements can be classified into non-functional and functional here. And if you take into consideration the non-functional requirements, these are all product requirements, such as we can break down into product requirements, organizational requirements, external requirements. So let's have a look at this diagram, and then I will explain some key things, but you look into each of them. Okay. So in terms of product means the system itself, because now we are talking about the information system, right? So non-functional requirement related to the products could be, as we already discussed, issues related to usability, efficiency means how fast, right? When we talk about efficiency, we usually say, oh, the system should be fast. So that is about efficiency. Dependability, security issues, it should not be hacked or something like that. We should use this and that algorithm for protecting the system or something like that. Okay, efficiency is about performance. It could be about the capacity or space as well. Because, for example, you should say that the system should allow you to store millions of users, millions of customers. So that is about the space requirement. But if you will say that it should be able to respond in the peak period when we have millions of users using the system. That is also about the performance, right? Sometimes during the Black Friday, sometimes during some peak period, if we talk about e-commerce system, you will have millions of users logging into the system during that promotion period. Okay, organizational requirements could be related to environment requirements, operational development requirements. And for external requirements, things could be related to certain regulatory, ethical, legislative, okay, which can be further considered as safety, security, accounting requirements. I think these are issues that all of them are non-functional. You can think of some examples. Regulatory maybe is required, right, by laws that you need to, for example, every now and then, when you store customer data, user data, you need to ask for consent. So every record before storing into the database need to be sure having consent from the user. This is some kind of requirement from the external, but it is not about functional, right? It's just how you must do things. Before you store data, you need to be sure of asking for consent. Okay, I think we already explained from those diagrams. Okay, so I will skip. Example, suppose we're talking about a medical care center. Okay, so we may say that, oh, the center, the system of the center, okay, the system of medical care center should be available during normal working hour. That is this. Outside this hour, operating hours, fine to shut down, okay, no problem. But during these operational hours, things should be up and running. This is about, I think, which types of functional requirement it explained. It can be also operational requirements, right? The operating procedure. It can be related to performance, because here it says that downtime, here downtime should not exceed 5 seconds in one day. This is clearly the performance issue. The system should, dependability issue as well. System should not crash down or become unavailable. Okay. This is part of the product requirements. Okay, we talk about organizational requirements such as we require by the operational procedure, every user must authenticate before using. This is operational requirement, and it is non-functional, requiring every user to go through authentication. And external requirements, because of the related regulation in terms of medical data and so on, and medical related regulation, it may require that this has to be followed. Okay. Okay. Would you like to change your answer? Anything? Shall we confirm here? A, functional. Are we confirming? B, non-functional. Still confirm. C is unknown. I mean undecided. Before it was undecided. So now what do you think? One or two, functional or non-functional? It is non-functional in the sense of usability. We provide help text in 3 languages to increase the usability to users who may be not able to use some language, right? Okay, are we confirming this? Easy to use? Yes. Search, this is functional, right? Search function. Here, F, what is it? 1 or 2, functional or non-functional? Yes, non-functional. If we say that user profile should be inserted, I mean the system provide insertion function, yes, it is functional. But we are not talking about the system providing insertion function, right? But we are talking about how many users the system should be able to handle. The same for this point C. You may say that, oh, the system should provide help menu. Okay, help menu is a function, right? Give the help function. But we are not talking about providing help menu. We talk about if there's a help menu, they must be in these 3 languages. So you need to be able to consider what is the main focus, right? In that statement. Okay, sometimes it confuses you because of this. Again, this is the focus is about this number of profile. Okay. Okay, then we have a few more. Okay, let's go quickly. Web application. Okay, we are talking about list of requirements for a web app. The application shall accept customer order. Functional, right? The application shall be able to cash sale. Functional, right? Receive payments by cash, I believe. Compute the cash. Receipt. Web application shall be easy to use by our employee, including sales representative and manager. Non-functional, and which one? Usability. Yeah, that is very usual, right? Usability is often described in terms of non-functional in many of the requirements. Available in several languages. Again, non-functional. Thank you. Produce receipt detailing customer purchase. Okay. Functional, right? It should print the receipt. Okay, show the receipt. Produce weekly, monthly, yearly reports about sale. 1 or 2? 1, functional, right? It's about producing the report. Okay, but the detail of the report, there are many types of reports to produce. That's fine. Allow sales to be made at the same time without downgrading the performance. Yes, non-functional, especially the efficiency category in terms of the performance, right? Okay. And another thing to emphasize, and this is very important, because still, even I emphasize, I still see kind of not 100% mistake in the sense that you cannot capture functional or non-functional, but still, what would be a mistake is that usually we should state the non-functional requirement in a way that is precise and objectively defined. Not that it is difficult to achieve or verify. Sometimes we state something in a very subjective manner, such as when we say about usability, people often say, oh, we want the system that is easy to use. Okay, easy to you or easy to me may be different, right? You may find something super easy. I may find that thing super difficult. So sometimes these terms that are used to define the non-functional requirements are very vague or subjective. Okay, so of course, you can define the goals of the non-functional requirements, such as, of course, the goal of the general usability, we can say that ease of use is the goal. But then we want, when you state functional, non-functional requirement, make it verifiable. Nobody can argue, because then it's easy for you to get your system accepted by the user. Because some system may say, oh, still I find that the system is difficult to use. Somebody said it's easy to use, then someone may not accept the system, right? So make it verifiable means make it measurable and can be objectively tested, such as we normally have this goal for sure, right? System should be easy to use by whom? By medical staff, okay? And okay, it is a little bit more precise that user errors are minimized. Meaning that, what does it mean by the system is easy? Meaning that users do not make mistakes when using the system. So maybe we need to make it clearer and more specific, right? Okay, so this kind of system, suppose I'm working on a system to calculate tax. I am in the HR payroll office. Okay, payroll office. Normally I help our employees, or the system will provide function for employee to submit tax form, income tax of every year, right? So user will need to fill in all these financial data, which is difficult. So if the system are easy, errors should be small or zero, right? So that is one way. You can test it. So you can say that, how can we verify that the system is easy? When we test it with real user of 100 users, errors should be less than 5%. Okay, then we can say that first, it is easy. Second, when you develop some, launch the system, maybe some pilot testing with some scenario of usage. Okay, we have scenario 1. All the tax data is like this, easy, not very many things to fill in. Scenario 2, oh, there are a lot of incomes, a lot of deductions, a lot of this, a lot of that. So scenario 2 and then scenario 3. For each of the scenario, you may need to define that. I think if the system is easy and helpful, first, yes, for each scenario, what is expected errors? that should not exceed. Second, how long time does it take for user to complete? If the system is so complicated and difficult, user may take 1 hour, while compared to another system which is better designed with usability in mind, maybe it takes 20 minutes maximum. So these are things used for measuring, not by saying that, oh, the system should be easy to use. So how can I know that my system is easy enough? Okay. So again, if we go back to the medical center system, instead of saying, of course, the goal is to make it easy with few errors, we can then define verifiable non-functional requirements as after 4 hours of training, that means half day. After half day of training, if the system is supposed to be easy, we should be able to train within half day. Okay. And then average number of errors made, okay, should not be more than 2 per hour, and so on. So this is example of how we define quantifiable, measurable requirement. Okay. So here are some suggestions. Definitely, we often talk about speed. Oh, the system should be fast. Okay, what does it mean? Right? So you should, instead of saying the system should be fast, you should say that for regular transactions, the number of processing, number of transactions that can be processed by the system should be 100 per 1 second or something like that, right? You should have some measurable. So these are examples of the thing. Instead of saying the size, it should be able to host up to 200 million customer or something. Okay, you measure in terms of size. You can convert that each user profile would take about this and that, and then convert into the size. Okay. Ease of use can be training time, number of help user needs, right? How many times user need to click on the help? How many times user make an error? Something like that. Reliability, failure, availability, and so on, robustness, and so. What is the way to measure them properly? Okay. All right. So this is the entire process. To recap again, when we talk about requirements engineering, usually these are common process that could occur. First is about the elicitation of requirements, then analysis of the requirements, then making sure that they are correct, right? So the validation of requirements, and then also management of requirements. Management means requirement may change, requirement may evolve, requirement may have additional one, obsolete one, and so on. So management would require maintenance, update of those requirements. Okay. And we can think of the requirement engineering process as a spiral, iterative process as well. Okay. And once you obtain the requirement, you analyze or model the requirement somehow. Okay. As part of the requirement process, the specification is also things we have to learn. But how much you will need to define or specify the requirements, it depends, right? But anyway, you need requirement specification to some extent. Otherwise, you have nothing to communicate. Requirement specification is a process of writing down documenting them in some form. Okay. Usually requirement specification or requirement documents are the same thing. But when we talk about, oh, okay, this is a process of requirement specification, it looks kind of very good process, right? It's actually the same as the requirement documentation. It's the same thing, but there are more specific way and proper way when we talk about requirement specification, such as we should use these types of diagram to model these types of requirements because it's more standardized and so on. And the goal of requirement specification, of course, is to document them properly. There's still the two types of requirements, system and user requirements, okay? In which user requirement, as I already said, focus is for communication with the users, okay? System requirements, the focus is more on the technical detail, and it will be used for the development team and also to confirm with the contracting stuff issues as well. Okay, ways to write. Natural language. There are pros and cons for each types of notation. Ways to write requirement specification can range from the very unstructured to the very structured, very unsystematic to the very systematic. Why? Natural language, oh, you can express anything in any way, right? You can write things, explain, go here and there, whether you explain well or not well. It's difficult to control the quality when things are written in natural language. So that is the drawbacks of explaining things in natural language. Better structure natural language means maybe you have some kind of standard template or form, right? It has some structure. Instead of allowing you to openly write anything in your way, explaining things from your understanding. With some structured form template, you okay. Description, functional requirement section, non-functional requirement section, here and there, this has more structure. Stakeholder, user, groups of user, and the list of functions that each group of user would use or something like that. This is more structure, okay? But still, natural language. Next, design description language, such as something that is more specific and systematic. Maybe programming language like, so it has some specific meaning, specific structure. So in this way, it's more in terms of less ambiguous, okay? So actually, if we use this axis, we can see this is more of the unstructured. This is more of the very structured. Or this is more of the ambiguous. This is more precise. Okay. From top to down, you can actually find where is each notation. Okay. Next could be graphical notation, of course. This is most common way to communicate requirements properly. Of course, you still need to combine, right? You cannot just have diagrams without some text explanation or natural language explanation. You still need to combine, but anyway, graphical notations supplemented by text annotations. Okay. are used to describe fit perfectly for the functional requirements. And we will learn what has been used popularly would be UML diagrams. UML, we will learn through this course important UML diagrams. Not every UML diagram, but important one. So important ones include UML use case diagram, class diagram, sequence diagram, activity diagram, etc. And these are very commonly used ones. And the last the last way of making specification is through mathematics specification too. Then this becomes very precise. Okay, based on mathematics concepts such as finite state machines, okay, sets, and many other types of algebra and so on. But of course, these are very formal language and not very good for communicating with the users for sure, right? Even for the group of developers, among the group of developers, not everyone would understand some of these mathematics notation too. So we need to choose well. Okay. So what I will quickly introduce are important ways we can use. The first one is use case and use case documents and use case diagram. So use cases, the word use cases, they represent, or it means when we say that what are possible use cases of this system, it means it will list down, right, the ways different types of users would be able to use the system. So that is the meaning that the things that use case would capture, use case diagram would capture. There is also the text document part and also the graphical diagram part. So it could explain to some extent scenarios of usage scenario for the system. And the users, when we represent or draw use case diagram, the users are called actors because they perform certain things. So that's why they are kind of actors. Okay. But anyway, I think I will quickly summarize and then show you an example. Okay, so when we say that a diagram includes a set of use cases for the system, so it means that it describes all possible interactions that a user can have with the system. So with the use case diagram, it shows that what are main functions, who are main users, and these users interact with the system through which functions. This is what we can see from use case diagram. So it gives a very good overview of our system. It is very high level. So very detailed technical things will not be seen by the use case. So these can be, first thing is easy. If it is the graphical model in terms of the diagram, it is easy to understand. Again, oh, what does it mean, Ajahn? You are talking about something very vague, right? I said already that easy to use, easy to understand. It's very vague. It means that even non-technical users can understand from this diagram what does the system do. So that is meaning of what I mean. Usually we need some description alongside with the graphical model. Okay, here is an example. A very simple example of a system which is called online shopping system. Okay, I should not draw this. Okay. So let's say that we are drawing or making. Again, this use case diagram represents requirement of the system. Okay. But more important to say, only functional requirement. It captures only functional requirements. Because how can we say? I will explain first. This is online shopping system use case. Okay. This oval notation represents one use case. So in this example, we have 4 use cases. First one is the use case of view item, make purchase, complete checkout, and log in. There is no order. Don't worry. Oh, Ajahn, why do you do the login last? No, there is no order. There is no sequence and no order. It's just say that there are 4 use cases, 4 functions, 4 main functions available to the user. And these users we call actor, and we represent by this kind of user notation, graphical notation representing a user like this. We call actor. It can be a human user such as customer. Actor can be also other system such as PayPal, credit payment service, or somebody else. Okay. And let's focus on only the main user customer, because this is easy. What customer can do? From here, you can see align means that the actor can perform the use case, that specific use case. Customer may perform the function view item provided by the system. A customer may perform make purchase, a customer may log in. Okay. Complete checkout, there is some other things inside. We will talk about them later. Don't worry about it now. Something like here, include here an internal relationship here. Okay. But basically, this is easy, right? General users who are non-technical users would be able to understand in principle what does the system do. Okay. One key caution when we talk about requirement, when you design, model the requirement, make sure that it captures what the system does, not how. Because requirement document is not a design document unless it is really a requirement. For example, it may say that we must use this technology because we need to integrate with another system and so and so and so. And this technology is a must to use. Because if you talk about the technology to use, the programming language to use, the database system to use, and so on, that is not requirement. That is design, right? You are specifying how the system should be developed. You are not describing what the system should do. Key point of requirement is just to capture what does the system do, not how. What the user wants to use the system. How in this case means how in terms of the technology. Okay, then we move further to the validation of the requirements. Once you model the requirement, you need to validate, right? Make sure what you model, specify in the specification somehow capture correctly what the user wants. Validation techniques could be such as review of the requirements, making prototyping, making test case. To make a walkthrough test case, you don't have a system to run yet. So this test case doesn't mean running a system and test it against the system, right? But walking through with some sample scenario test case, that if this case happens, all the requirements your model can handle all possible cases. Okay. And the requirement management means we allow requirements to evolve. Not that now you learn the requirement from user, no change can be allowed. No, you need to admit that change could happen. Okay. So we can start from an initial requirement, but still we could go through the changing, and finally the requirements have to be changed according to the time. Okay. So this is what I already mentioned. Process of requirements management is kind of managing the changing of the requirements during the system development period. After the development period, if you're still with the system, of course, you continue managing the changes, right? And evolve the system. But if you already leave, of course, the other team who come after you may need to take care after that. Okay, this is to recap a little bit, okay? About functional, again, describe what the system should do or perform. What specific services the system would provide and deliver to the user. Okay, and then of course, if possible, we want complete and consistent requirements. No contradictory, conflicting. This one says something, another say another thing, or something like that. Should not be there in your requirements specification and document. Complete means everything that should be there is captured and explained. But I often say this, right? If the system is small, users are very familiar, user knows everything, complete requirements is possible. System is still unknown. We are still thinking of a new system. It's very difficult, right? To make sure that it's complete. You come to the user for meeting with the user for 10 days, learning all these things from the user. And finally, user say, yeah, I think that's all that I want. But do you think it could happen that the next week, next month, user, oh, I think I still have missed something. I just see some example of other system. I just come across with this idea. I just pop up with this interesting stuff. And then he will come to you, right? And say, oh, I have some change. I have something more. So complete requirements never exist. Okay. And I often refer to this because sometimes nowadays in private sector, business sector, we are more towards the agile methodology. We understand that things change very fast. Having a very stringent process and stringent requirement specification, requirement document would be challenging or impossible. So business mostly understand, but then very difficult in government projects because of the rigid procedure they have in terms of the budgeting, approval process, and documentation, and also the contract. Okay. So these have to be very careful in terms of managing the requirements and the documents. I put this in the pretty last part of the requirements in terms of agile method and related to the requirements, because we now accept and understand that producing detailed system requirements, this is very strong, is a waste of time, as it will be changing, especially in the changing business world. Okay. Wasting of time in the sense that if you need to wait for 1 or 2 full months to completely complete the requirement process and then move to the development process, then we hope that this 2-month process of requirements understanding will be complete and done and no more change. And then you have a very easy life that you coding all this system after these 2 months, right? So it is not the case. So that is very waterfall, and we already discussed, right? This is the drawback of waterfall for changing requirements. So in the agile, that is why we use iterative. We don't use waterfall for the system that is likely to include unclear requirements, changing requirements, and so on. So it is true in the sense it's not completely 100% true for every case or every project, but nowadays it's most likely true for most of the types of the project. So with Agile, we focus on incremental requirements engineering. First, we try to understand the big picture, then we work on specific requirement, one or a few at a time. Instead of suppose from the overview of the whole picture, we have a picture that there might be 20 things, 20 functions, but broad understanding, right? But going into the deep detail, we choose the core one first. Instead of, it doesn't mean that you don't know everything. You know the rough detail. Remember the Mona Lisa drawing? You know the rough detail of Mona Lisa. You know the whole things about the project, roughly. But then you fill in specific parts or clearly understand more and more for some specific parts, okay? And try to work on that specific part one at a time. Instead of making Mona Lisa picture clearly from the beginning, which takes time. And finally, Mona Lisa may change her face somehow, okay? So we have rough picture, blur, roughly. We fill in more specific detail one by one, depending on the priority of the system or the importance of the component, okay? That is Agile. Use incremental method. Okay, so very practical nowadays, but as I said, could be difficult for some government restriction, government project restriction, due to the procedure that they may have restricted this thing. Okay. We will talk about these things when we move on more detail of Agile modern approach. We have the concept of product backlog, user stories, and more. But okay, here in terms of teamwork, I decided with the users, the product owners who will be your users, to move it after midterm exam so that you don't have to worry with many things. So we will focus and start working intensively, actively from the after midterm exam week, okay, on the project. Okay, and I think that is for this slide about requirement specification, in which we focused on functional, non-functional, and some of the techniques used for requirement specification. Okay, up to now, any questions? Everything is still clear, right? Okay, let me see. If I can continue with this, it is another 20 slides. I think I can start now, but let's see whether I can really finish them. Okay, so the screen sharing. So this is the last set of slides focusing on use case diagram. Okay, still related to what we discussed, right? Remember, we already talked about this, that the concept of use case are used to identify, represent, depict system behavior or system functionality that a user would interact with. An actor is the drawing, symbol, diagram, right? In the drawing, in the diagram, an actor is a user symbol that represents external entity interacting with the system. Can be a user, can be other system, can be something, some other component of other system. That is fine. May not necessarily be a person. Okay. And this is another example of a use case diagram. You can see we have here the use case for university system, university registration system, in which we may consider in this system who are actors, what are functions or behavior of the system. So actors mean those who involve with the system and make use of the system, right? Interact with the system. Actor, we have student, we have bursar's office, we have registration clerk or registration officer, we have instructor. These are main actors interacting with the system. But how do they interact? Student interact by, in this notation, in which I would say that most of the common standard way of writing a use case, this should be there. I mean, the name of the use case should be inside the oval. Okay, so please move the use case title inside the oval. Maybe I should redraw this later on. But sorry that yeah, I took this example and then did not remake it. Okay, anyway, kindly note that our convention, okay, for our convention that we follow so that we have the same standard consistently among all of us and actually widely used all over the software industry. That is, use case title should be inside the oval, and oval represents a use case. So student can register for classes. Student can mainly, okay, interact with the billing function, okay, make payments or something related to the billing, in which the same for bursar's office, because bursar is something related to money stuff, right? Also work on this use case. If we talk about instructor could register for special class. Okay, this is very specific to the requirement. So don't answer why it happened like that. Okay, this represents model some example system in which it may be similar or not similar to AIT. Okay, maybe we should model the AIT's one. Okay, we should do. AIT's one represent AIT registration system using use case diagram. But anyway, To understand this, you can see that registration officer can interact with this use case and so on and so on. Okay. So in summary, we use the use case diagram to show system behavior along with the key actors that interact with the system. But the key actor specifically interact with specific use case, not every use case. Okay. And these are definitions in symbol. Make sure that every use case you draw a boundary. A boundary means it represents that this is inside the system and actors are outside the system. So you could see every actors, they are outside the system. They interact, but they are not part of the working system, right? And then we will talk about this later on, include and extend. These include and extend allow us, a connection or a line. You see there is no arrow in general connection. When actor interact with use case, no arrow because there's no direction. Usually it's the direction that the actor perform or interact, right? So no need to draw any arrow. But with extend and include, there will be arrow because they represent relationships that several use cases may have with each other. So there will be an arrow giving the direction. Okay, so there are two. There should be an arrow here. There are two types of relationships, include and extend. Okay, we already talked about actor, system function or a use case, a boundary. Okay, a connection. Okay, they are here. We use include relationship to identify or to indicate that one use case, let's say use case A. Yes, I forgot that it has to be adopted. Okay. Use case A includes means something like invoke. So use case A would invoke or make use or include use case B. That is the meaning of include relationship. Usually it allows us to make why do we need to use include? Because sometimes yes, because it could happen in this case. And we should say include. Okay, so in this case, it means that use case A make use of use case B. Also use case C make use of use case B. Okay. Such do I have yes. Such as this. This is inventory system. Let's say there's a supplier, there's a manager, there's a use case reorder supply produce management reports. Okay, with the reorder supply, it make use of a use case track sales and inventory data. So this could do some kind of data query. Okay, this use case of track sale and inventory data focus on querying related data about sales made, about inventory level we have at the moment. Then the reorder supplies use case could call and check, right? That, oh, are there any items that have low number of stock level and need a reorder, an automatic reorder or something, for example, or a reminder or notification for reorder. Okay, and at the same time, another use case such as produce management reports would need to invoke or call this use case as well, because it needs to do data query related to inventory, stock, and so on. Okay, so this is an example of using include. This use case include the usage of this another use case, and there could be many more. Another example of using include would be authenticate or login. Many systems require the login, right? But before you can do many other use case or perform, before user can perform any function, we need to make sure that authentication is checked. User is the authorized one, something like that. So you can have only one authentication use case, but all the other use cases would require this. Okay, that is also another example of using include. So about extend. Extend means that you add an extension. So that is clear from the definition of the word, right? Extend. So one use case extend another use case. So in this case, we are saying that use case B extend use case A by adding some functionality or something. Let's look. Oh, okay, not this one. Okay, yes. In this case, you can see that here we have a common or general use case, which is called register. Let me remove. Okay, here we have register use case, register for classes, which is kind of basic process of registering a class, right? But then there might be some special way or specific procedure of some special class. Then this use case of register for special class extend the normal behavior of basic use case register for class. So usually we use extend when there are some kind of new specialized behavior, but most of the thing remain similar with the existing one. But we want to add some special cases, some specialization, some specific behavior or procedure into the existing one. So this allow us, so with the include and extend, it allow us to make kind of relationships among use case. Otherwise, you have all the very independent use cases, which are not true in the real system, right? Some use case are kind of call or make use of other use case. In that case, we use include. Some use case would be an extension to some existing use case, and so on. Okay. So this is what I say here. So we can say that here A is a general use case. B is an example in this case of a specialized use case. Maybe, for example, We do have general use case such as register for course to normal students. We do have specialized use case for kind of register for courses, but for exchange student. For example, normal student, you have you have minimum 9 credits registration, maximum 15. For exchange, maybe, oh, they are on exchange. We don't put this restriction of minimum. 3 is fine, but maximum may be the same. So this is specialized. The same for InterSem. Register for courses during, normally it's the regular semester, right? But for InterSem, you define as specialized use case for the InterSem registration, because InterSem minimum is 3, maximum is 9, which is in terms of credits registering. So these kind of condition and maybe some procedure could be different as well. So in that case, you make use of extend. Okay. Okay. Next that I will explain is about written or documentation of the use case, explanation of the use case. It's about document, additional document, additional explanation to describe how the use case work step by step. So this alone, this kind of diagram alone, even it is kind of self-explained to some extent, still there are not enough detail for developer to understand how it works, and also for users to understand the detailed step. So with the use case document or written use case, okay, you need to have, this is a kind of template or some structure. These are some examples of the structure we should include in the use case document. Of course, the title, the actor. Okay, we will look into each of the examples here. Suppose this one is buying a product from an e-commerce website. Okay, this company, we develop a system which is an e-commerce or web-based system for customer to purchase online. Okay, so definitely in a use case diagram, there will be a use case. This has to be very corresponding. Buying. This is a document that explains or describes the given use case. Buying a PDF ... Okay, this is the same. There must be an actor, namely customer, because it is here. Primary actor is customer who interact with this use case. And of course, if you have more and more and more use case in your diagram, each use case should have associated document like this. So we explain each use case. So what does it explain here? It says that this is a use case buying a PDF product at web store. Primary actor is customer. Level of explanation is a summary level. I have here, when you explain, oh, if you are very descriptive, right? You can explain things in a very deep level. So this range from summary to detail, how much you want to explain. White, as seen from the clouds. Kite, bird's eye view. Blue, sea level view. Fish below the sea level, or black, bottom of the sea. Okay, I would suggest this is good enough. Otherwise, you will have very detailed step. And then again, time and effort putting into making documentation will be too much, right? We want good enough. for communication and understanding. Good enough document. Okay, so in this use case description, this is what we call use case description. This is what we call use case diagram. Okay, when we say that we make use case model, we need two things. We need a use case diagram, one diagram only for system. It's not only because sometimes you can break down, but usually if your system is not too complicated and require a very big diagram to be decomposed further, one could be enough to give a big picture. But it could be that we require more than one diagram. Okay. But then for each use case, this oval, we have associated use case description to explain things in some detail. So what do we have? Okay, we were up to here. High level. Who are the stakeholders? What are preconditions? What are minimal guarantee? Success guarantee? What triggers this use case to execute? Why this use case choose execute, right? For example, customer access the web store is the initial trigger. Okay. Main success scenario means what if there is nothing wrong and there is no kind of branching. So this means common step of the use case when no errors, no exceptions happen. Such as usually when you want to buy something, you can click cancel, right? You can go through from step 1 to step 10 and finish, check out. You can go to step 1 to step 5 and you say cancel. You can go to step 1, step 2, and then your internet break down, you disconnect. You go to step 1 to step 7, almost done, but then something happened. So there are always exceptions along the way. Success scenario means nothing happened. We expect a very smooth life, but usually that you should be very pessimistic, right? Define all possible things that could happen along the way too. And that is defined here in the extension part. If something could go wrong or not following the main success scenario, what could happen? It may not be that something go wrong, but it can be just, oh, I cancel. Or you are about to move to the last step of payment. And then you find out you don't have credit card, or you make a bank transfer, but you don't have enough money in the bank account. Oh, everything can happen at any step, right? So these need to be defined here. So such as customer browse catalog, what could happen? Catalog not available. Maybe the database breaks, connection crash. So if catalog not available, customer may quit, or customer may click retry or reload, refresh. What if customer place order for the desired product? Okay, this is main successful scenario, right? What could go wrong? Order transaction is interrupted. Interrupted, what happened next? Transaction roll back. Of course, you need to roll back the database in transaction, or transaction roll back, but customer starts again. Or transaction roll back, but customer decide to quit, no more, I don't trust you. And so on, right? Item step 3, shipping fills the order. Try to manage delivery. What could go wrong? Product out of stock. Oh, we cannot deliver, we don't have the item. Okay, so what could happen next? We notify the customer. Oh, sorry, we thought we have the product, right? But it's run out of the stock. It will take another week. Do you want to wait? So The thing is customer want to wait. Or another scenario, we notify, but customer say, no, we cancel. I don't wait for you. So these are things that you may need to think about possible scenario that would happen. Okay. The last main success step, right? We check the status, but then the status is not available or blah, 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 and so and so. Okay. So these are all these are the explanation of, oops, sorry, the format. So we need title, we need title, actor, and these are explanation of what does it mean for each of these items, as I already explained in the example. Okay, so last thing, I think you need some exercise. This is one possible exercise you could do as a self check